In this video, I'm going to show you how to multiply and divide rational expressions. We will look at a variety of examples and discuss how to state restrictions. Let's start with the following example. We're trying to multiply two rational expressions. In order to multiply two rational expressions, all we have to do is state the restrictions on the existing denominators and multiply across, numerator by numerator, denominator by denominator. If there is a possibility to reduce any coefficients and factors, we can reduce them before multiplying. Let's start. So in this case, we have two denominators, x plus 1 and x minus 1. So the restrictions will be x cannot equal -1 and +1. Those two values will make my denominators, the respective denominators, 0. And we don't want that because we cannot divide by 0 since the value of the expression will be undefined. Now that we have stated the restrictions, let's see if there are any terms that we can reduce. For example, are there any coefficients in the numerator and denominator that can be reduced? Are there any variables that can be reduced? One of the most common mistakes that students make is, say, reducing this value and this value here. This is one of the common mistakes, but one of the bad mistakes. So you cannot reduce like this because the denominator has an addition. You're adding two terms together, x plus 1. All of that is one expression, and you cannot separate it. So you cannot reduce the x at the bottom with the x at the top because the x at the bottom is not isolated. It's not a separate factor. All right, so we cannot really reduce anything here. So we can go ahead and multiply numerator by numerator, denominator by denominator. Let's multiply the numerators first. We multiply coefficients. 2 times 3 6. X squared times x to the power of 1. We keep the base, add the exponents, x cubed. And y exists only in the second expression, so we're going to multiply by it, 6x cubed y. In the denominator, we'll multiply the two expressions, x plus 1 times x minus 1. Now we can expand the denominator as well. And I can see almost identical expressions, only with opposite signs. This prompts me that this is a difference of squares. So in the numerator, I still have this, and in the denominator, I can write it as a difference of squares, x squared subtract 1, with the above restrictions. Let's consider the following example. We're going to factor before we continue, since we have common factors that we can take out in both numerators. In the first one, we can common factor the 3 out, and we'll get x plus 2 over x minus 4. In the second one, we can common factor the 2 and get x minus 4 over x plus 2. Now let's state restrictions. The restrictions on the denominators that I have here will be x cannot equal -2 and +4. And let's see if we can reduce any factors. I can clearly see that I have 2 and 2 factors that are identical. X minus 4 and x minus 4 can be reduced. X plus 2 and x plus 2 can also be reduced. This is possible because this is multiplication. If I was adding or subtracting the two expressions, I would not be able to reduce them like that. So now that I have reduced the same factors, I can multiply the coefficients or whatever has remained. 3 times 2, and it's just 6. So the value of the product of the above two expressions is 6. In order to divide two rational expressions, we need to start by first factoring, then stating the restrictions on the existing denominators, then taking the reciprocal of the second expression or the dividend, flipping it upside down so that the denominator becomes the numerator and the numerator becomes the denominator. Change the operation from division to multiplication, and then see if we can reduce any factors. After that, multiply. Let's try that. So we're going to factor the numerator, and we'll get x minus 3 times x minus 4. And in the denominator, we have x minus 1 divided by x minus 3 over x minus 4. The restrictions here will be x cannot equal 1 and 4. Now we're going to have to take the reciprocal of the second expression. Let's do that. So we copy down the first expression as is. Then the second one will become x minus 4 over x minus 3. The operation will change to multiplication. The restrictions have also now changed. We need to add a new restriction, a new denominator that we have created, which is x minus 3, so x cannot equal 3. So we now have 3 different restrictions. And now that we have done that, we can see if there are any factors that we can reduce. So in this case, I notice that there is an x minus 3 in the numerator here and x minus 3 in the denominator here. So I'm going to get rid of them, and I'm going to multiply what's left. X minus 4 times x minus 4 over x minus 1. And x minus 4 twice, or squared, is the perfect square trinomial. X squared minus 4x and 4x, negative 4x, so 8x and plus 16 all over x minus 1.